Hey everybody, it's Masara back with you. Today we're going to go in a little bit more in depth on solving compound inequalities with the ands and the ors. So we've only got a couple of problems to go through today, so just remember a couple of things. When you've got less than or equal to or greater than or equal to, you've got closed circles. When you have just a less than or a greater than, you have an open circle. Remember, ors are going to go off in both directions, whereas the ands should have two endpoints and be shaded in between. So let's run through a couple of these problems and make sure everybody is on the same page. So with the ors, remember you're solving each problem independently. So we're going to solve n plus 9 is less than or equal to 8. Nice and easy. Subtract 9 from both sides. We'll get n is less than or equal to -1. So let's graph that. Less than or equal to is a closed circle. At -1, less than shades to the left. Let's change colors to do our other side. So we have n divided by 9 is greater than or equal to +1. Remember, to get rid of division, we want to multiply both sides by 9. So we get n is greater than or equal to 9. So we're going to have a closed circle at 9 and go off to the right. Remember, with an or problem, you should end up with something looking along those lines. Now, with number 2, we have an and problem. Now, they've given you this and problem split up as two separate equations, which is fine. Sometimes we have to split things into two cases, even with an and problem. So let's take a look at each part of this and. So if we're going to do this problem right here, 6n is greater than or equal to -36. Let's solve for n. We divide both sides by -6. That means that we divide each side by 6, which means n is greater than or equal to -6. Now, if we solve the other side of this, we have n divided by 6 is less than 1. Well, if we multiply this side by 6 and this side by 6, we get n is less than 6. Well, let's look at how this would look on the graph. If we said n was less than 6, we would have an open circle at 6 and be shading to the left. But we also need it to be true that n has to be greater than or equal to -6, which means we have a closed circle at 6 and we're going to shade off to the right. Now, you'll notice there's overlap here. The answer to the problem is simply that. It is the part that overlaps. So we're going to take off everything that extends past our two endpoints. So we will end up having a closed endpoint at -6, an open circle at +6, and everything in between. Remember, ands are the in-betweens, and the ors are the ends. So if we take a look at problem number 3 is the other way that they can show you an and problem. They didn't put the word or and in this problem, but the way that they wrote it with two inequalities, this is what we call a compound inequality. That's their way of saying this answer is going to end up looking like an and problem. So let's rewrite it down here and we'll solve the whole thing. So -55 is less than or equal to -6x minus 7 is less than or equal to 23. So we saw a problem like this on a previous video. We're going to work from the inside and try to get x by itself. So we're going to get rid of this -7 by adding it to both ends. That will cancel it out in the middle and leave us the -6x is less than or equal to, well, -55 plus 7 would get me a -48, and 23 plus 7 would get me 30. Now our job is to divide, but now you'll notice here we have to divide by a negative. Well, if we divide by a negative on all three of these places, that means both of these inequalities have to flip over. Well, -48 divided by -6 is going to give me not a -8, a +8. Whoopsies. So we'll get a +8 is greater than or equal to x, because the 6's cancel. 30 divided by -6, we got to flip the inequality. That's going to be a -5. Now, if you were going to try to graph this, you'll notice -5 is usually on the left and 8 should be on the right. So I would suggest that you flip this whole inequality around to make it look appropriate to our number line. -5 is less than or equal to x is less than or equal to 8. So when we graph it, -5 gets a closed circle because of the or equal. So -5 gets a closed circle. 8 gets a closed circle. And we shade everything in between. Now in problem number 4, we have an or problem. So let's work in 2 separate colors so we can keep ourselves organized. So we have -4 plus 7v is less than or equal to 24. Let's add the 4 to both sides. So we've got 7v is less than or equal to 28. Divide by 7. And we end up with v is less than or equal to 4. So we can graph less than or equal to is closed. Less than is left. We'll change colors. Let's do blue. So now we have 7v minus 2 is greater than or equal to 68. We'll add 2 to both sides. That leaves us 7v is greater than or equal to 70. Divide both sides by 7. And we've got v is greater than or equal to 10. So greater than or equal to, closed circle, shade to the right for greater than. It's an or problem, so we expected our graph to have 2 ends, and it does. The last 2 problems, we have an or and an and. The and is really the only odd case that I'll show you. This is actually a problem we're going to have to split and do 2 separate cases on, but we'll get to that in just a minute. So let's do our last or problem. So let's do in 2 colors so that we can stay organized. So 4 minus 8m is greater than 2m plus 4. Now we have variables on both sides. My suggestion would be simply to move the negative to move the 2m, because we're used to having our variable on the left-hand side. So if we do that, we get 4 minus 10m is greater than 4. If we subtract 4 from both sides, we get negative 10m is greater than 0. Now, the trick here, even though we know the answer is 0 on this side, because 0 divided by anything is still 0, we have to remember that our inequality flips over because we had to divide by the negative 10. So we have m is less than 0. So open circle at 0, shade less than. If we do the other side of this, we get 3 minus 2m is greater than 7 minus 6m. So again, I'm used to seeing my variable on the left, so I'm going to add the 6m to both sides. So I'll be left with 3 plus 4m is greater than 7. Subtract the 3 on both sides. So we get 4m is greater than 4. Divide both sides by 4, and we get m is greater than 1. So I have an open circle at 1, and I shade off into the greater thans or the right side. And you'll notice that means that the only part of this number line that is not part of our solution is the numbers starting from 0 and all the way through the number 1. Now, getting to number 6. Number 6 is the odd man out, because the easiest way to solve this, you'll notice you have variables in all 3 sections of this equation. This is an and equation, but I will tell you that the easiest way to solve this is to rewrite this problem as an and problem. So we're going to rewrite this problem as 2 separate sections. Negative 6n minus 5 is less than negative n minus 10. We're going to solve just this first portion and get one answer, and then we will change and we will solve the middle 2 portions. sides. Okay, so we're going to do this in two separate sections, and I'm going to have to take that line off of there. Otherwise, our number line is going to get messy. So let's solve these first two equations right here. So if we had to solve this, again, I would lean in the direction of adding n to get your variable on the left because that's where we're usually most comfortable. If you want to put the ones in front of here, you can. So we get negative 5n minus 5 is less than negative 10. We're going to add 5 to both sides. So we will get negative 5n is less than negative 5. Divide both sides by negative 5. And that will leave me with n is greater than, because we divided by a negative, a positive 1. Now, if we want to work the other side of this, we're going to start from here and work to the end. So we'll have negative n minus 10 is less than or equal to 4 minus, let me take this up so it's out of our way, 2n. So if we wanted to solve this equation, I would suggest we add the 2n to both sides. Again, trying to get the variable to the left. This will cancel. Well, negative 1 plus 2 is 1n minus 10 is less than or equal to 4. Add the 10 to both sides. Now here, if you want, you could drop the 1 off if you wanted to and say n is less than or equal to 14. So n is less than or equal to 14 means at 14 I have a closed circle. N is greater than or equal to 1. Let's go back to that blue color. If it's greater than 1, we're going to go to 1 and have an open circle. And because this was written as a and problem, we're going to just shade everything in between. So that's the only time I would suggest highly that you use what we call split cases to handle that problem, okay? Because otherwise it's going to get awfully messy for you. So if you ever have trouble with an and problem, you can always split it apart like that and work it as two separate individual problems and then graph your solutions. Just remember, ands overlap, which means you're only looking in between, and the ors extend off in both directions. Your homework tonight on Edulastic is going to have 10 problems on it, focusing just on your inequalities. So let me know if you have any struggles, and I will look forward to seeing you guys next time. Thanks so much for watching.